Okay, we're going to get started here. This lesson is going to be on counting techniques. And then counting techniques, we are going to have the video broken up into two parts. This part is going to be combinations and permutations, and part two, or the other part, I guess, is on the counting principle. So if we look, combinations and permutations, we kind of got to understand a few things before we actually get started into determining different combinations and permutations. First thing, you have to understand what a factorial is. If you look, a factorial is used with this symbol. I know it looks like an exclamation point, and if you were in an English classroom, it would be an exclamation point, but we're in a math classroom, so we're going to call it a factorial. And what is a factorial? It's just if you take, let's say you have 5 factorial, it's just you start at 5, and you multiply every number down to 1. And when you multiply those numbers, 5 times 4 times 3 times 2 times 1, you're going to get 120. Or if you're looking at 8 factorial, that would be 8 times 7 times 6 times 5 times 4 times 3, 2, and 1. 40,320. That's what we talk about a factorial as. If you had 100 factorial, 100 times 99 times 98, and I'm not going to say all the numbers, but that's what dot 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 means. You follow this pattern of going down one number until you get to 3 times 2 times 1, and then whatever that is multiplied out. You can try and multiply that out by your calculator. Some calculators may tell you it's too large of a number to multiply in it, and some other calculators may give you a number in scientific notation. But for this, I'm just going to leave that one there for you. Okay, if we look, there is a special case, 0 factorial. 0 factorial is going to be 1. 0 factorial is always 1. I'm going to let you, this is kind of my definition of what a combination and permutation is. I'm going to let you read this on your own for one moment, and then I'll come back with you. What a combination and permutation will do is it'll let you find the number of ways in which you can pull a small group that is less than or equal to the whole group. So like say, if let's say you had a basketball team, there are 12 guys on the basketball team, and the coach is going to choose 5 of those guys to be in the starting lineup. How many different starting lineups could the basketball coach put on the basketball floor? A combination and permutation is going to help you to figure this out. If you're talking about that situation, in which the coach is putting a starting lineup on the floor, it doesn't matter the position that those players play. Combination will be how you solve that situation, because order does not matter. If he's just picking 5 guys to start, that'll be a combination. Now, if he's picking 5 guys to come out of the locker room, and then, right at the beginning of a game, they come out of the locker room, they run around the gym, they do some basketball drills and stuff, and they do that in order. If he's picking that order in which they come out of the locker room to do the drill, that would be a permutation, because order will matter in that case. Here are the formulas. I guess I probably should have said an N, and this is in both formulas. N is the total number of whatever we're talking about. In the situation with the 12 players on the basketball team, 5 for a starting lineup, 12 would be n. And then r is the objects chosen, or the objects taken. Either way, objects chosen or objects taken. And so for the situation for the basketball team, 12 players on the team. This is going to be a combination because order does not matter. He's just choosing 5 guys to start the basketball game. And then you would set it up from there. N would be 12. So we say 12 factorial on top, and then on bottom, n minus r. 12 minus 5 is r factorial, and then you're going to multiply by r factorial. Again, you multiply by r factorial. And that's how you set up the problem. We're going to get into more of those problems here in one moment. If you look, that asterisk that I just covered up with that green, whenever you see an asterisk here, that's going to mean multiply. All right. N is the total number of objects that you have, and R is the number of objects that you're choosing, or that you're taking out of the whole group. In a permutation, order matters. Say we choose the first 3 numbers, 1, 2, and 3. Right? 1, 2, and 3. We're trying to figure out the number of ways that you can order these numbers. If order matters, in a permutation, order does matter, there's going to be 1, 2, 3, 4, 5, 6 ways to order those first 3 numbers in an order, so that way they don't, and you're not going to be able to use the same number again, like you can't use 1, 2, 3 again. So there are 6 ways to order those numbers, so order does matter. If order does not matter, this is the one way, because if order does not matter, as long as you choose 1, choose 2, and you choose 3, it doesn't matter if you choose 3 and then 1 and then 2. Order doesn't matter here because you still have chosen 1, you still have chosen 2, and you still have chosen 3. And that's all it's asking, is how many ways can I pick those 3 numbers? And if those 3 numbers are the only numbers you're choosing from, of course there's only one way to pick them, because it doesn't matter which one you pick, first, second, or third, you're still going to get all 3 of those numbers. Let's look at this situation. We're going to work these out. If you feel confident in working these out, you go ahead and work them out, and make sure that your answer matches mine. You just pause the video and then hit play, and then watch my solution and make sure it matches yours. 18 people trying out for the basketball team. The coach intends to keep 12 of them on his roster, or on the roster. How many different roster choices does the coach have to create the team? Well, order isn't going to matter here, so we know order does not matter in a combination. He has 18 guys to choose from, and he's only keeping 12 guys on his team. So that's the reason why we are going to write it 18C12. And make sure the 18 and the 12 are small numbers down below, kind of like a power would be a small number above. 18 and 12 are subscripts. That's what they're called. Sub means down below, and there's scripts, subscripts. So let's go ahead and plug it in. You have to have the formula memorized. If you don't have it memorized by this point, you can just use the notes there. On top, you should have 18 factorial. On bottom, 18 minus 12 factorial. And you're going to multiply that. Since this is a combination, you multiply it by r factorial again. And so this is where we're at. I know that 18 minus 12 is going to be 6 factorial. Okay. 18 factorial is going to be 18 times 17 times 16, 15, 14, 13 and 12 factorial. Try and get all this over here so that way it didn't run out of room. Okay, and now on the bottom, and you might ask, why did I stop at 12 factorial? Because let's look at the numbers that we have on bottom. We have 6 factorial and we have 12 factorial. And I didn't continue writing 12 factorial on the top because it's just 12 times 11, 10, 9, 8, all the way down to 1. And this one right here on the bottom is just 12 times 11 times 10, 9, 8, and so forth, all the way down to 1. And what I'm going to do is I'm just going to cross these off. They cancel out. And the factorial signs will cancel out there because, you know, 12, 11, the 11s are on top and bottom. The 10 is also on top and bottom. The 9's on top and bottom, the 8, and so forth. All those numbers for 12 factorial that are on the bottom are also on the top. So we're going to cross those off and cancel them out. Sometimes when you use a factorial, you get a really large number, and those large numbers aren't always easy to work with. So this is where we're at. Let's go ahead and multiply these numbers out. If you multiply the numbers out on the top, 18 times 17 times 16 times 15 times 14 times 13. When you multiply those numbers out, you should get, I'm going to write that down here. And what number is that? 13,366,080. And on the bottom, 6 factorial. 6 factorial is going to be 720. So now we just take those two numbers and divide them out. You should get 18,564 ways for the coach to choose his basketball team if 18 people try out for the team and he's only going to keep 12 on the team. 18,564. Okay, let's move on to the next one here. The next one, there are going to be 20 athletes competing in the high jump event on the track and field team, or on at the track and field, maybe invitational, maybe. It's a larger meet. So how many different ways can points be awarded to the top 6 athletes? Okay, so if we're awarding points, first place is going to get more points than any other place, and second place will get the second most points, and so forth. Third will get the third most points. Well, if we look here, since the order matters in which these athletes finish, first place getting the most and sixth place getting the least, this is going to be a permutation. The total number of athletes competing is N, which is right there at 20. And how many are going to be scoring points? 6. And so we have a permutation. Now we're going to set this up and solve it out. On top you have N factorial, so that's 20 factorial. On bottom you're going to have 20 minus 6, that's N minus R there on bottom. And so what is the number that we have on bottom? 20 minus 6 is going to be 14 factorial. And on top, just like we did in the last problem, we're going to stop at 14 factorial because that number is on top and it's on bottom. So 14 factorial and 14 factorial will cancel out. Remember to put the factorial sign after both of those because there's a difference between 14 and 14 factorial. So you're left with, on the top, you're left with those numbers there. So go ahead and take your calculator and multiply those, unless you can do it in your head, which would be great. Probably a lot quicker than multiplying it in the calculator. And in doing so, we have another large number. There are 27,907,200 ways in which, from 20 high jumpers, 6 of them can receive points. Let's look at the next one here. When shopping for your lunch, you have a choice of 8 different types of fruit. If you intend on buying 3 types of fruit for your lunches next week, how many different arrangements of fruit could you purchase? Okay, well, you should be thinking there are 8 total types of fruit. You're going to be buying 3 of them. Does it matter whether you buy the bananas before the oranges or even both of those before the apples? It doesn't matter because in the end you're still taking the apples home the same time you're taking the banana and the oranges home. So it doesn't matter the order in which you purchase these. So since order does not matter, that will be a combination. And we know that there are 8 total fruits that you could choose from, and you are actually buying 3 of them. And so you set it up like this. You have 8 factorial on top. Now on bottom, I typically, in the last few examples, I've wrote down 8 minus 3 and put it there. I think we can calculate 8 minus 3 in our head. 8 minus 3 is going to be 5 factorial. And that's just to save a step. Let's save a little bit of time. That's to, do something in our head. And since this is a combination, we have to multiply it by r factorial here. Now, you might be asking yourself, 8 factorial, what do I have to multiply it down to? You multiply it down to whichever one is the highest out of those 2. 5 factorial is the highest, so we're going to multiply 8 factorial down to 5 factorial. And then you'll have 5 factorial on the bottom and times 3 factorial. And what numbers can we cross off here? Well, we can cross off 5 factorial on top and bottom. Now, I'm looking at this problem. If we can cross off 5 factorial on top and bottom, well, we could also do some reducing here. You could just do 8 times 7 times 6, which is a number, and then divide it by 3 factorial. Or you could say 3 factorial. Well, 3 factorial is 3 times 2 times 1. And what is 3 times 2 times 1? Well, that's 6. It's not 6 factorial, it's 6, because 3 factorial is equal to 6. Now, 3 factorial is 6, so maybe you see the 6 on top, and you see a 6 on bottom. Cross those off. You cross the 6 off on top, and you cross the 6 off on bottom. And in crossing the 6 off on bottom, you're crossing off 3 factorial, which is equal to 6. And so then you can do the rest of this in your head. What's 8 times 7? 56. 8 times 7 will be 56. And so that's the answer here. There are 56 different ways that you can buy 3 fruits when having a selection of 8 to choose from. This situation here, how many different ways can 5 people be seated at a table? Well, if you're thinking about it, if you're sitting at a table, the first person that sits down, let's say, you know, the first person that sits down, that'd be Billy. Billy sits down in a chair. Well, Billy is not able to sit down in any other chair because he's already sitting down at a chair. And then the next person, Susie. Susie sits down next to Billy. Well, Susie can't sit down in any other chair because she's already in a chair. So in this case, order will matter. Order will matter. Or that's a permutation. Now, how many total people are going to be sitting down? You have 5 people that'll be sitting down. Or you have 5 total people, and all 5 of those people will be sitting down at the table. And this is a permutation. I believe you probably could have used the counting technique to solve this one out, or the counting principle to solve this one out, but since this video is on combinations and permutations, we will do it using combinations and permutations. So we say n factorial, which is 5 factorial. That's on top. And on bottom, you have n minus r. Well, what is 5 minus 5? That will be 0 factorial. And that's what we have. And I had 0 factorial on one screen all by itself. It said 0 factorial is equal to 1. And we know 5 factorial is 5 times 4 times 3 times 2 times 1, 120. And therefore, 120 is our answer here. There are 120 different ways that 5 people can sit at a table. Remember, if you feel comfortable enough to pause the video, try and work it out, and then check your solution. That's the whole goal. We're trying to get you to be able to do this on your own. So if you need to do that, go ahead and do that. This situation, the lieutenant has asked the staff sergeant to choose 2 squad members for guard duty. The squad consists of 9 members, so how many different options does the staff sergeant have to choose from for his pair of guards? Well, if you think about this, does the order matter in which he chooses these 2 guards? It doesn't matter, because they're both still going to go down and do guard duty. So if order does not matter here, that would be a combination. How many total members does the staff sergeant have to choose from? The squad consists of 9 members. That's the total number of members. How many is he actually going to be choosing to go to guard duty? 2. He's only choosing 2. So let's go ahead and set this up. On the top, you'll have 9 factorial. On bottom, you have n minus r, which is 9 minus 2. 9 minus 2 is 7 factorial. And since this is a combination, you also multiply it by r factorial again. You're going to say 9 times 8 times 7 factorial. And 2 factorial on bottom. And we go to 7 factorial for the simple fact that 7 factorial is on top, 7 factorial is on bottom. We can cancel those out. We also know that 2 factorial is equal to 2, 2 times 1, which is 2. And so can we reduce 2 with anything above? Can we reduce 2 with 8, or can we reduce 2 with 9? We can reduce 2. We reduce 2, and we reduce 8. 2 goes into 8 4 times. And so then, since we reduce this 2 factorial, 2 times 1, 2, all of that cancels out. And so now we have smaller numbers to multiply. The only numbers left that aren't crossed out is a 9 and a 4 now. What's 9 times 4? 36. There are 36 different ways that 2 squad members can be chosen out of a 9-member squad to do guard duty. In Major League Baseball, the National League teams do not use a designated hitter. The designated hitter is in the American League. The American League uses the designated hitter, and the designated hitter bats for the pitcher. Typically, the pitcher is not a very good hitter, so that's why in the American League, that's why the designated hitter bats for the pitcher. So we're going to talk about a situation here. So let me restart this problem again. In Major League Baseball, the National League teams do not use a designated hitter. Therefore, since pitchers are typically not good hitters, the pitcher for the National League teams is usually the last batter in the lineup. If teams bat 9 players and the manager intends on his pitcher batting last, how many different batting lineups can the manager set? So if we think about this, there are, how many guys are batting? If you look, there are going to be 9 players batting, and the last one batting will be the pitcher. Well, okay, if the manager's batting 9, the pitcher is the last one. So, how many different guys does the manager have to arrange in a batting order? Well, there's only going to be 8 guys left, because if he has 9 slots, the pitcher's in the last one. There's only 8 slots open to put in his position players. So if we look, is the order going to matter here? The order will matter here. Number one, it is a batting order, but also the first baseman cannot bat twice. I know some managers would like to have their first baseman or their power hitter, or their best hitter batting more than once, but that's not the case. So the order matters. Each player can only bat once in one spot. Order matters is a permutation. Remember, like we said, he's only arranging 8 in the lineup because the pitcher is batting last. And how many different guys does he have to choose from? Well, let's see here. What are we looking at? Last batter, if teams bat 9 players. So we're only talking about the starting players. We're only talking about the players that are going to start the game. So 8 of them he will be arranging, and that's how many he has to choose from, and he is arranging all 8 of them in the lineup. And so we work this out on top, n factorial, on bottom, n minus r factorial, which is going to be 0 factorial, and 0 factorial is 1. And so on top, we have 8 factorial. If you, there is a factorial button on most calculators, so if you can find it, sometimes there's a PRB button for probability. Sometimes you have to hit, like, I know if you're using a Texas Instruments graphing calculator, you hit math, and then you go to the right over to probability, I think. Most of them are that way. So, 8 factorial, 40,320. And 40,320 over 1 is just 40,320. So the manager has a lot of options to choose from. This is a situation, typically the manager puts his fastest guy first, the next 2 guys are decent hitters. The third guy might actually be a power hitter, and the 4th guy and 5th guy are usually some power hitters too. And then the guys more down towards the bottom of the lineup typically don't hit as well. But, we're using just the real life situation so you can think about some things. So you can understand what a permutation is and what a combination and when order matters. How many hands are possible if you are dealt 5 cards from a standard 52 card deck? Say you're playing a card game and you are dealt 5 cards. Is the order going to matter in which you're dealt those 5 cards? Probably not, because if you get the Ace of Hearts first, or if you get the Ace of Hearts last, it's still going to be in your hand. So you're going to have the Ace of Hearts. Doesn't matter when you are dealt that card. So combination. How many total cards are in the deck? 52. And how many cards are you dealt? 5. And so we work this out. 52 factorial on top, and on bottom, 52 minus 5 is 47 factorial. And you're going to have a combination, so you multiply it by r factorial again, and in this case it's 5 factorial. So let's go ahead and work this out. 52 times 51 times 50 times 49 times 48 times 47 factorial. On the bottom, we have 47 factorial times 5 factorial. We know that we can cross off 47 factorials. And let's go ahead and multiply those numbers out. I could change 5 factorial to something like 5 times 4 times 3 times 2 times 1. And therefore, like I know 5 and 2 will make 10, which will reduce with 50. But I'm going to have to use the calculator anyways to multiply those large numbers out so I can get those large numbers quickly. Let's just go ahead and multiply them all out and divide them. Well, I already know 5 factorial is 120 because that was our example for factorial. Plus, we've used it once or twice, so starting to get that memorized. 52 times 51 times 50 times 49 times 48 times, that's it. When you multiply those, is it 311,875,200? I believe so. And then when you do this, you will divide that 311,875,200. You'll divide that by 120, and you get, it's still a large number. I think it's 2,598,960. And that's the wow. There are 2,598 ways, or I'm sorry, 2,598,960 different ways that you can get 5 cards dealt to you from 52 card deck. If we look here, there are going to be 8 swimmers entered in the race. How many ways can they finish the race? Well, if we choose 8 swimmers, how many ways can they finish the race? Is order going to matter here? The question isn't asking how many different ways can they finish the race in first, second, third, fourth, fifth, sixth, seventh, and 8th place. They're just asking in how many ways. Actually, you know what? That is what it's asking. How many ways can they finish the race in first, second, third, fourth, fifth, sixth, and 7th, and 8th place? So that's why it's permutation. There are 8 total swimmers, and 8 of them will be finishing the race, and we're trying to figure out how many ways can they finish the race. So this is where we are at. 8 permutation 8. 8 factorial will go on top, and on bottom 0 factorial. And I remember from a few problems ago, this was the same exact problem we worked out. It was just a different situation. 40,320 went on top. We know 0 factorial is 1. So therefore I answer 40,320. Different ways that those 8 swimmers can finish the race. How many ways can your favorite 7 songs be played when you use the shuffle mode of your favorite songs playlist if the songs are not to be repeated? Well, if the songs are not to be repeated, and there's a certain order in which they're going to be played. Because once a song is played first, it cannot be played ever again. And so if we look here, there are 7 songs that you have as your absolute favorite songs. You have 7 power songs here. And how many of them are going to be in your favorite songs playlist? Well, all 7 of them are. So we know on top, 7 factorial, and on bottom, 7 minus 7 is 0 factorial. And 7 factorial divided by 0 factorial, well, we know 0 factorial is 1. And on top, we have 7 factorial, and 7 factorial is going to be 5,040. And there are 5,040 different ways that you can listen to your 7 favorite songs. I hope this video helped you out a little bit. If you have any questions, make sure you stop by and see me, or else you can shoot me an email if you are not if you're not one of the people who see me on a regular basis. That'll be all we have for today. I appreciate you watching. Thank you very much.